right, so now we're going to combine equations and inequalities and absolute value, which you've done in the past, but we're going to take all these ideas and look at them all at the same time. So let's first review absolute value, and then the other phrase, extraneous solutions, and then I'm going to show you what we're talking about, okay? So let's scroll. All right, so absolute value is the distance, the distance a number, and we'll call that number n, is from 0 on a number line. And it's written, remember, with bars. Okay? So absolute value is actually a distance. And since you can't ever go a negative distance, absolute value is never negative, because it's, yes, it might be to the left or to the right, but you don't care about the direction. You just care about the distance. How far or how many steps does it take this direction or this direction? Because you can never go negative in any sort of distance or measurement or anything like that, okay? So that's the absolute value, and it says the distance, a number, is from 0. So that's from on a number line, and then we write it with those bars, okay? And then extraneous actually relates to what I mentioned already, and that is an apparent solution. And apparent means it looks like it's a solution. Like when you say, well, apparently this, you're saying, well, it looks like whatever it is you're talking about. So it looks like a solution, an apparent solution that must be rejected. Okay, must be rejected, meaning you have to throw it out. Okay? So it looks like an answer, but it's not. You have to throw it out because it does not satisfy the original equation. Okay, and by not satisfying, we're saying not satisfying right there, we actually are saying that it is not true. When you check it, it actually will not be a true, it won't work out as true like we've been checking our answers in other problems. So let's put that over here. Does not check as true. Okay, that's what extraneous means. So when you check it, it's wrong. Okay, so even though it looks like it's an answer, even though you did the work right, it actually can't work, okay? And we have a lot of extraneous solutions in Algebra 2, so this is just our first exposure to it, all right? So we're actually not going to do the next section. So for the next section, I want you to just put a big X through it. So I'll show you just so that we can move on. All right, so this next part, okay, I really don't like it. I don't think, I'll explain it differently as we work on it, okay? So you can just take a big X and put it through this section. Okay, we're going to skip that part because that definition stuff is just, it's a little confusing. And then you can do it for the bottom part as well. Okay, so this whole part of this page, we're just going to skip the bottom part so that I'll just tell you kind of how things work and what it means and what it looks like as we start doing our examples, okay? So on the next page, me erase the X so you don't think it's crossed out. All right, on the next page, okay, we are going to work this out. All right, and what it means, okay, if you think about it, if we go off to the side and I say, well, the absolute value of n is a 10, okay? If it's a 10, then that means n can be two different types of numbers. That means n could be a positive 10, because when you put 10 in there, you get 10 out. Or n could be a negative 10, because if you put negative 10 in, when you do its absolute value, you still get 10 out. So you actually get two values for n. I don't know if you can see that over here. So you actually get two values for n. It could be the positive version or the negative version, because the bars make that 10 positive in the end, okay? So it would be the same way for, like, if I had the absolute value of k equals 17, okay? Well, what could I put in here to get a 17 out, a positive 17? I could put in a positive 17, or I could put in a negative 17. Either one, when I put it in there, will come out positive, because those bars are going to make either one of these come out positive. So even though one's to the left and one's to the right, they're still the same amount of distances away from that 0. Okay? So that's what we want to look at here. So when we solve it, this is the inside and it equals 6. Well, that really means that inside could be a positive 6 or it could be a negative 6, okay? Because regardless of which type of 6 you get here, the bars are going to make it come out as a 6, okay? As a positive 6. So let's look at this a little bit more. Okay, so again, these bars are going to make whatever's in here positive. So it could be a positive 6. Let me see if there's anything. A positive 6 or a negative 6. Okay, the same or the opposite. Okay, because inside will always, because those bars, will always make it a 6. So then you just solve. Well, I add 3 to both sides, and I get a 9 over here. Or I add 3 to both sides, but be careful, that changes to a negative 3. So I have two answers. One is 9, and one is negative 3. Okay, so the solutions are 9 and negative 3. These are the values of x that are 6 units away from 0 on the number line. These two numbers, if you put it in here, you will get positive 6 or negative 6, but the distances are both 6, okay? Well, actually, we'll go off to the side and we'll check it so I can show you why that works that way, okay? So on the number line, though, it's just, let's see. Oh, and sorry, I said that a little bit wrong. They're 6 units away, but instead of from 0, it's actually from 3 because when we added 3, that's kind of the center to it. So here's the center, okay, because when you add 3, that kind of centers it, because if you notice, we added 3 to both sides. And if you notice, 9 is down here, and negative 3 is down here, and they're both, let me put a 3 right there, and they're both 6 steps away. 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4, 5, 6. Okay, so regardless of which side you came from, it is 6 away. And the reason why 3 is that center is because when you got x by, the way you got x by itself is that you moved the 3 over. So moving that 3, since we did it on both problems, that's kind of the center that we're looking at here. Okay? So another way you could think of it is by checking it. So if I were to check it, I put in 9, because that's the first answer I got, the absolute value of 9 minus 3, does that give me a 6? Okay, well 9 minus 3 is 6, and the absolute value of 6 is a positive 6, so that checks out. Okay, now let's look at the negative 3, the other answer we think we get. So again, we go back to the beginning. Instead of x, let's put in the other answer, negative 3 minus 3. Okay, so negative 3 minus 3, that's a negative 6. But the absolute value of a negative is positive still, so it still checks out. Okay, so again, whether you get a positive 6 inside or a negative 6 inside, they both come out as positive 6. So that's why they both check. So you can check your answers and show that they both work, or you can think of it, how far away are they from this center, which in this case was a 3, because that's the opposite of what we have in there. Okay? When we solved, that's what we did. All right, so the same thing for the next part. So let me erase this. All right, let me erase this and let's look at the other two. So this is kind of like the ones I talked about already, and that is you've got two different 5s that could come out of this. Since you're not adding or subtracting anything, there's just 2 options for what could come out as a 5. And that is, you could have a positive 5 in there, because that'll come out as a 5, or a negative 5, because that'll come out. So in this case, 0 is the center, because you didn't have to add or subtract anything when you solved. And if you notice, 5 and negative 5 are the same distance away. They're both 5 steps away. 1, 2, 3, 4, 5 steps away. And 1, 2, 3, 4, 5 steps away. Okay, so either one works for solving them. Okay. Now in this case, you either want a positive 2 in here because it'll come out positive, or a negative 2 in here because it'll also come out positive. So let's say x minus 5 equals 2, or x minus 5 could equal negative 2. Either one of those comes out of those bars as a 2. So then it's a pretty easy step. We add 5 to both sides on all of them. That's our center, because that's how you move. So we're going to center the number line on that 5 that we just moved. And so we get 2 answers, 2 different answers. X is 7, or X is 3. Okay? So if X is 7 or X is 3, if you notice, here's 3 and here's 7. They're still the same distance away from that center. Since we had to add 5 out to get rid of it, that's our center. But if you notice, that's still only 2 steps from the left. Let me use a better marker. That's 2 steps from the left, but that's still positive, that positive 2 that we got, or 2 steps from the right. That positive 2. So either way, it's still 2 steps away, okay? Or you could check it. In this case, checking might be better for you. So that is, if we think it's 7, the absolute value of 7 minus 5 is 2. Well, 7 minus 5 is 2, and when you take the absolute value of that positive, it's still positive, so it checks. And then let's try the 3. The absolute value of 3 minus 5 is a 2. 3 minus 5 is negative 2, but when you take the absolute value of that, it pops out as a positive 2 as well. Okay, so again, whether you have a 2 or a negative 2 inside the bars, they both check out. Okay, they both make that 2. All right, so let's finish out this page just by talking a tiny bit about absolute value equations, okay? So it might already be something we've already addressed, but let's finish this page out before moving on into the inequalities and the number lines and stuff like that. So, finish this out. Okay, it says, use these steps to solve where we don't equal 0, because 0 is its own case, okay? Write the equations, and so we have talked about this already. Write the equations as ax plus b equals a positive c, or ax plus b equals a negative c. It's exactly what we've been doing. You can either have a positive or a negative in there, okay? So step 2, we just want to solve it, like we have been. And then step 3, we're going to check for that extraneous, like we were going off to the side and doing. So these next problems are probably going to be a little bit more set up, like we've already talked about, regardless of, you know, what we have equaling over here. So check the solution in the original absolute value equation. If you notice, whenever we've checked, we've gone back to the beginning that we were given, and we tried all of those numbers in there, okay? So again, the positive version or the negative version, and then check it, all right? And then that's what we'll be practicing on the next page, okay?